Okay, so I'm going to take that first function 2x plus 1. I'll put it into my y equals on my calculator. I'm not super concerned about the graph at this point. What I'm really concerned about is what's happening at 2, at x equals 2. So I'm going to hit second graph to go to my table. And then where I'm going to go is to when x is 2. So basically what I'm using my calculator to do, I'm using my calculator to evaluate this function at that point. You can most certainly plug in 2 and get 5 out, but like I said, I'm a cheater, lazy person. So I'm going to make a note that for this function, when x is 2, y is 5. That's the ordered pair 2, 5. So on my graph then, I'm going to plot that point. At 2, 5, I'm going to plot that point. Now you might remember from Algebra 2 that a lot of times in piecewise functions, we have closed-in dots for some functions, we have open dots for others. What determines whether it's closed-in or open? Josh, do you remember?
It's either equal, then, or less, or among the less.
Right, so why did I close that dot in? Right, because for the first function, that is the function that includes x equals 2, okay? From there, I'm concerned about x values less than 2. So on my table, I'm going to go to an x value that's less than 2. I usually choose integer values, so when x is 1, y is 3. I'm going to plot 1, 3. And you can pick as many points as you want. I usually do, I don't know, 2 or 3. So if I pick another x value that's less than 2, let's say 0, my y value is 1. So at this point, I'm getting a pretty good idea. What? Okay. Getting a pretty good idea of what that graph looks like. Just be really, really careful that you draw this line in the correct direction. I'm going from that initial point to values less than or equal to 2. Questions on that much? Good? All right, let's look at the next function. What is that, ladies and gentlemen? It's a horizontal line. It's a horizontal line. At 2, when x is greater than or equal to 2. What? Exactly. So at 2, 2, so when x is 2, y is 2, because from here my y values are all 2. Like Avery said, I have an open circle going towards x values greater than 2. Bless you. Little side note here, just listen. Let's say you just are, I don't know, rushing or, you know, whatever happens, and you accidentally fill that in. What's wrong with this whole thing now? But these are piecewise functions. So if I were to accidentally fill that in, what's my issue? It's not a function anymore. Because if I accidentally fill that in, that means when x is 2, my y values are 2 and 5. So just really watch yourself that you're not making careless mistakes. You can always remember your vertical line test. If I hit a vertical line that touches my graph twice, it's not a function. So just watch that, okay? When I have that one open, it still passes the vertical line test because it's only hitting my line once. Okay? Just a little side note to think about. All right. Any questions before we look at the next one? Okay, here we go. So, cheater lazy way. I'm going to take x plus 4, plug it in. Look at my table. And this time, I'm concerned with when x is -2. So I'm going to scroll up a little bit. When x is -2, my y value is +2. So at -2, +2, I'll start my initial point with a closed-in dot because it is or equal to -2. And again, I'm looking for x values now that are less than -2. So scroll up. So -3 is less than. So at -3, 1. I have another point. You could do it again if you wanted. -4, 0. So we get a pretty good idea what that part of the function looks like, and I can graph that in. The second part of my function, again, is a horizontal line. This time it's between x values of -2 and 2. So if we kind of go back to what Connor said, this is a situation where they do connect. So notice that this one is starting off right where the last one ended. And that horizontal line is continuing until x is 2. I ended that with an open dot because this is just less than x values that are 2. And then finally, we can look at that third function, 4 minus x. Oh, this time I want +2. So when x is 2, my y value is 2. So once again, where the last one left off is where my next one begins. So where that open dot ended, I'm going to go ahead and fill that in for the next function. And then we can use our table to get a couple more points that we need. What questions can we answer? We okay? Take a deep breath. Here we go. That was piecewise functions algebra 2 style. Let's go piecewise functions pre-cal style. So now we're putting these functions into some sort of context. The charge for a taxi ride is $1.50 for the first fifth of a mile, 25 cents for each additional fifth of a mile. And we're rounding everything up to the next fifth of a mile. All right, first part says to sketch a graph of the cost function C as a function of the distance traveled, assuming that we're just going from 0 miles to 1 mile. Technically, We've talked about a taxi ride problem before. You could technically go forever, but that's not really reality. Bless you. So, a couple of things that we need to do before we sketch this function. We need to change the scale that we have here. Because we're only going from 0 miles to 1 mile or 5/5, what I'm going to do is change this to 1, 2, 3, 4, and 5. And what those are representing are 1/5 increments of a mile. So the 1 isn't 1 mile, it's 1/5 of a mile, and so on. Similarly, going up our y-axis, our charge for 1 mile is nowhere near $10. So let's change this scale as well.
Do by 25 cents.
You want to go by, well, how about we make this first one 150? That way we don't waste like all that space, you know what I mean? So let's make that 150. And then if you want to go by 25 cents, that seems logical. And this is our total cost. And why did I go from $2.25 to $3? Oh goodness. How about $2.50? Is that better? And that's our total cost in dollars. Now we have a scale that better fits our situation. Okay, now that we have that settled, now let's graph. So how are we going to graph the fact that up to the first 1/5 of a mile, our total charge is $1.50? How can we represent that? What's the charge for 1/10 of a mile? What's the charge for 1/20th of a mile? Okay. So all of these distances cost $1.50. So all of these are going to be $1.50 up to and including 1/5 of a mile. So we have hit 1/5 of a mile. As soon as that taxi rotates its tires even just one more time, you've gone beyond 1/5 of a mile. So one tire rotation beyond 1/5 of a mile, what happens? It jumps up to 175. So what we have to show is that we're not including 1/5 of a mile, but everything after that is 175 all the way to where? 2/5. That pattern then continues. After 2/5 of a mile, one more tire rotation, we jump up to $2. All the way up to 3/5 of a mile, and so on. This is a type of piecewise function that we call a step function because it looks like stair steps. Okay. Alrighty. So we have part A. Here's the hard part, is part B. Finding a formula to represent this, okay? So our total cost is equal to $1.50, and then we need to specify that that's the total cost, bless you, between what interval of x. And we're going to kind of base it on how we made this graph and how we made this scale. So our total cost is $1.50 between what values of x? 0 and 1, exactly. Now, what about when we hit beyond 1/5 of a mile? This is the hard one, because here's what you guys want to say. That's what you want to say, and I totally get that. But what is wrong with this? What?
It's not taking into account when it changes from the different fifth miles.
Can you elaborate on that a little bit?
Sure. Because it says $1.50 for the first 1/5 mile, it doesn't show that it's for the first 1/5 of a mile in that equation.
Right, okay, so let me ask you this. If we said that this was between 1 and 5, if I'm looking for 4, the cost of 4/5 of a mile, you would plug 4 in here, right? But that's not correctly calculating the cost. Because the first 1/5 is $1.50. I should only multiply that quarter by the next 3/5 of a mile. So we have to figure out how to write an equation that takes that into account. Here's what we're going to do. We're basically going to go back to Algebra 1. We're going to pick a couple points that we know is true within that interval, and we're going to write an equation. Okay? So I know that if I am going 2/5 of a mile, my cost is $1.75. Would you agree with me? Okay. I know if I'm going 3/5 of a mile, my cost is $2. Agree with me there? So I'm just, again, picking 2 ordered pairs, 2 coordinates from within that second interval. Find your slope, write your equation. Okay? So my slope is going to equal 2 minus 1.75 over 3 minus 2. And we're getting the slope is the 0.25, which makes sense. That's the amount we're increasing every time we go with another 1/5 of a mile. But it's when we use our point slope form, so I'm going to use that second one because they're both integer values. It's when we put that slope in one of these points in our point slope form that it takes care of that issue we were having before with it not calculating the costs correctly. So I'm getting y equals 0.25x plus 125. Not matching up. Just double check your work a little bit. That then would calculate our costs correctly in that interval. Questions? Caitlin?
Why is there a 5? Just because that's where the graph ends.
Yeah, I'm thinking this is not 1 mile, 2 miles, 3 miles. These are 1/5 mile increments still. Does that answer your question? At the very, very beginning, we were told to only look between 0 miles and 1 mile. And since I'm looking at 1/5 increments, I just said 1 is 1/5 of a mile, and so on. Does that answer your question? Okay, Nick? It can.
Like that's 1 less than x is greater than 1, can be greater than 5.
Because it's equal to 1 up here. Can't be equal in both places. Then we have that function issue. Okay? Other questions? All right, last part. What is the cost for a 4/5 mile ride? You can use your function for that mile. You can use your graph. What's the cost? Nick? Yeah, $2.25.